Okay, so today we're talking about logarithms. Let's start with kind of a game type problem. So pick a number between 10 and 100. I'm just going to pick 52. Okay, so we're going to try to find out the answer to 10 to the what power equals 52. In other words, algebraically, we're doing 10 to the x power is equal to 52. And we don't know how to use algebra to do this yet. So in fact, it's technically not even called algebra. We'll eventually use logarithms to do this, but let's just guess and check it. So we do know how to guess and check. In fact, 10 to the first power is 10. 10 to the second power is 100. So I'm guessing the answer is somewhere between 1 and 2. There's actually a button in your calculator. If you look over here, right next to the number 1 there, it says 10 to the x. So we're going to guess, let's just guess 1.5 and see if that's equal to 52. Oh, 31. So I need to go a little higher, a little bigger than that. So 1.6, a little bigger. Maybe I'll try 1.8, I don't know. That's too much. 1.7. Okay. So 1.7. Ooh, it's between 1.7 and 1.8. Okay, so let's try a number between those two. So I'm going to go to another decimal. Let's try 1.75. That's too high. How about 1.72? I don't know. That's still too high. So it's between 1.70 and 1.72. Let's try 1.71. 51, so it's between 1.71 and 1.72, so it's 1.715. Let's go another decimal. Still bigger than that. Try to make it 8. That's too big. 7. Too big. 6. Ooh, that's too small, but we're getting close. It's between 1.716 and 1.717. So I'm going to say 6. Oh, I'm so close. I'm going to say 630. Too high. 6.1. Too high. So it's 7.6. Whoops. Oh, something. Maybe 0.5. Okay, how about 0.3? Still too high. We're getting close. Still too high. Still too high. Wow. Okay, so 0.2. Add another decimal. Getting so close. Still, I'm going to get it one of these times. Too high. Is 0.3 the magic one? So much. Yes, we finally got it. So we found that x is, after about 5 minutes or so, wow, that took a long time. So we figured it out. So it could take a while in your homework if you had to do that for every problem. Oh, and by the way, I don't think we actually found 52. Do you see that little decimal there? That means there's something hidden there. See the actual, oh no. We only found the answer to the nearest about 4 decimal places there, 0.9999, but we need to get it exact. There must be a better way than guessing and checking. I think there is. Let's try it. So we're going to use logarithms. So we have to learn what a logarithm is. Well, it's a pretty good definition right there. Short and sweet. Logarithm is an exponent. A logarithm is equal to an exponent. That's helpful to know. These are the two forms of logarithms. They're interchangeable. So one's called exponent form or exponential form. One is log form. And so we're going to identify some important characteristics in here. What I would recommend is identifying the base. So in a logarithm, this is a subscript. This is the base is down low. So the base is A there. It's down low. It's a subscript. It's not on the same level as the word as the letters log. That's spelled log. On the exponent form, what's interesting is also down low. Below the exponent is the base. So the base is so I sometimes when I'm trying to convert forms, I always do the base first because it makes it easier to kind of figure out stuff. Okay, so then let's look at the exponent here. So the exponent, well, clearly this is the exponent, right? On this side, that's easy to tell. If this makes sense, a logarithm is equal or is an exponent. So log is on the left side, is that equal sign, an exponent. This guy has to be on the other side of the equation. So this is the exponent is on the other side. Okay, and the other number goes in the other spot. So this is how it works. So let's try this one. Put this one into exponential form. So what exponent form? So what that means is you're going to have a number to some power equals some other number. So let's plug in what we know. So the base is 4. That's got to be down low. The log is an exponent. So 2 is the exponent. So 2 has to be the exponent. Another number goes in the other spot, which is here. 4 squared is 16. That actually kind of makes sense. 4 squared is 16, right? So log base 4 of 16 must be 2. This is a little higher end, but the way I think about it, when it's in log form, if I don't completely switch the form like we just did, you can think about it this way. 4 to the power of that side, 4 to some power is equal to 16. 4 to the what power is 16? 4 to the second power is 16. Let's go backwards. So we're going to put this one in a log form. So it's going to be log of some base, that's a subscript, of some number equals some other number, which should be the exponent. So 2 is down low. 3 is the exponent that goes on the other side of the equation for the log, and 8 goes in the other spot. So log 2 of 8 must equal 3, which is basically saying 2 to the third power is equal to 8. Okay, let's learn the properties. So I'm going to write them out. I'm going to write equals x first, and then we'll figure out what it is and replace that x with whatever it's equal to. Okay, so let's kind of work this one. So to solve something that's in log form, this chapter, get really good at changing the form, right? So the other form would be exponent form. So let's kind of think that through. It's a number to a power equals some other number. Let's see what goes where here. So a is down low. The other side, x is the exponent, right? So that goes here. And this is 1. A can be any number. So any number to the 0 power is, or 0 power, I'm sorry, x must equal 0. Does that make sense? So if that didn't, so you're basically saying what number goes there for x? 2 to the 0 power is 1, 3 to the 0 power 1. That's always going to be true. So this is equal to 0. So that's the first property. You can memorize these properties if you prefer, or you can derive it. When I say derive it, I mean change the form to figure out what it is. So that's kind of what we're doing, is we're just kind of deriving these. Okay, so equals x. So if you put that in the other form, what would this look like? So this would be a to the power of the exponents on the other side. So a to the power of x equals the other number, which happens to be a also. So a to the what power equals a to the blank power. It's understood the power is 1 there, right? So x has to be equal to 1, which is the answer there. But you're going to just plug in a 1 there. So log a of a is 1. So if you saw like what this problem might look like, this one might be something like this. Log base 3 of 3 is equal to 1, right? Because those bases, that base and that number match. Here, this problem would be something like log base 3 of 1 equals what? And that would be equal to 0, according to the property, right? So you can just memorize the properties if you want, or you can derive them every time. Doesn't matter. I'm just going to put equals, not x, because I don't know for sure if it's x here. So I'm going to write it this way and change the form. So a number to some power is equal to the other number. So let's plug this one in. This would be a is the base. To logarithm is equal to an exponent. So the exponent is that question mark, and then the other number is a to the x. Technically, by the way, I should have had this written as parentheses a to the x. The x should be inside of there. Sometimes I'm not as careful as I should. I shouldn't put that out. It should be in there like that. That's the actual property. And so let's derive it. So a to the what power is equal to a to the x? Well, that must be equal to x, right? So it was actually equal to x, really. So that's that property. So again, that a to the x goes there instead of a to the x in parentheses a to the x. This one, I actually wrote down the property for you. That is, I'm just going to derive it or change the form to make sure that you agree it is okay to write it this way. So what's weird is this is the hardest one. In fact, if I were to memorize one of them, I would definitely memorize this one. So if the form looks kind of like this, so if you have, so let's change the form. So log, it's an exponential form. So base a of a number equals another number. So let's plug this in and we get x goes here, and then the exponent goes on the other side, so log base a of x. I don't know if this makes sense, but yes, that's true. Log base a of x equals log base a of x. That's a true property. And that's a really good one to memorize. So what these problems might look like is you might see a problem like this, like 3 to the power of log base 3 of 8. If that was the problem, using the property, right, this 8 is going to be your answer. Got to be 8. In fact, sometimes I just do this. I see that those 3 log 3 matches. I just kind of draw a frowny face. I go, the answer is 8. And it is. If you have trouble, you can always change the form and derive it, but I was just using the property, just kind of memorization. So this one, the problem might look something like this. Log base 5 of 5 to the, let's be careful here. Let me put in there, and let me put the other part here. So this is 5 to the 9th. Would equal what? According to the property, as long as the A's match there, so 5 base 5, I see a smiley face, the answer's got to be 9, and it is. This is a fast way of doing that one. So try this on these 4 problems. Go ahead and press stop, derive these, or use the property. Somebody memorized it, maybe you're going to derive it every time. It's up to you. I'm going to go ahead and do them. So 3 to the what power is 3, 3 to the first. These are kind of easy, these first two. 7 to the what power is 1, 7 to the 0. Those are just properties. This was a property too, maybe a little harder to see. I see a frowny face, the answer is 9. But if you don't see that, let's just pretend we don't know. So I'm going to put it into log form. So log base 4 of x equals the exponent, which is log base 4 of 9. So what does 9 have to be there? So the property there is not actually equal to x. It's equal to, I mean, that the answer there is 9. Okay, in this one, you might just see the property. Again, if you saw the property, you might just go, oh, the answer is 3. If you don't see that, you can always kind of just put equals x here and change the form. This would be 2 to the x equals the other number. This should have been written as 2 to the third inside of there. So 2 to the third. So x must equal 3. It's probably obvious at that point. So x is equal to 3 there. Okay. There's one more thing. So this kind of harkens back to, harkens, why did I use that word? Okay, so square root of 5. Let's say, say square root of 9. So if you have a square root, you know it's understood that there's a 2 there. It's the second root of 9. 3 times 3 is 9. It's the second root. But no self-respecting mathematician writes that. They actually just write square root of 9, and it's understood there's a 2 there. We like to save that economy of writing here because we're kind of lazy. We don't like writing a lot. So we save that too because it's so common. Same thing with a logarithm. So if I wrote something like log of 7, and I just forgot to write the base, or I just didn't write the base, it's understood the base is base 10 because that is so common. In fact, a lot of calculators could only handle 2 bases, log 10 and log base e. And so it's just understood. If you see log, you're just kind of, well, I didn't write the log because it's understood the base is 10. So that's going to be a given. If there's no base listed there, it's understood that the base is 10. If it's just a regular old logarithm there. So let's try this one. So try this, don't stop the thing, try it, and see if you can do it. Again, if you're stuck on how to do something, just change the form. In this case, it's really going to help you to go ahead and write in there, even though to change the form, it helps to write the base of 10 there. It'll help you change the form. So this, if I change the form, this will be 10 to the x equals 100. But now this isn't such a hard problem. What is x equal to? Well, it's just 2, right? 10 squared is 100. This one, again, write the base in there. It's going to be helpful for you. So let's change the form. This would be 10 to the x equals 1 over 10. We have seen this a number of times, and hopefully you know the trick, and it really is kind of a trick. We're going to write this as 10 to the negative 1. A negative exponent moves things up or down. I didn't like that 10 in the denominator. So now I have 10 to the x equals 10 to the negative 1, so x must equal negative 1. So you get your answer there. That's it for the screencast for today. That was quick.